We will now determine the increasing intervals, decreasing intervals, and local maximum or local minimum from the graph of this derivative of the function. So remember that whenever the derivative graph is positive, the function has increasing intervals, and whenever the derivative graph has negative, the graph of the f of x has decreasing intervals. So we will replace this condition to determine the increasing and the decreasing intervals from this graph of the derivative of the function. So first let's find out the increasing intervals. For that, we have to look at the graph and determine in which interval the graph is positive. So clearly we can see that when we start from x equal to 0 till x equal to 1, the f prime of x is positive. So we write down this as one interval. This is one of the increasing interval. And once again, we go through this graph. After 1, it is decreasing. Looks like we have a negative. So till 3, it is negative. And from 3 to 5, once again, the f prime of x is positive. So in this interval, the graph of f of x is increasing. So we write down that interval, that is from 3 to 5, it is increasing. Afterwards, it is negative, so we can put them in the decreasing intervals. Now let's identify the decreasing intervals. We know that from 1 till 3, the graph of the derivative is negative. So we can write down from 3 to, sorry, it is from 1 to 3, the graph of f of x is decreasing, as well as from this interval, that is from 5 to 6, the derivative graph is negative, which means the graph of f of x is decreasing. So we write down that as interval 5 to 6. So this is increasing interval, and this is decreasing interval. We will now do part C, that is, we will determine the local maximum or local minimum of this function. So for that, we have to determine the critical numbers first. Remember that critical numbers are those numbers when the first derivative equals 0. So we can identify the critical numbers from the graph of the derivative. That is, at x equal to 1, as well as at x equal to 3, and at x equal to 5, the derivative graph is 0. That is, f prime of x is 0. So we say that we have three critical numbers for this function. So we will create a sign chart, and based on the sign chart, we'll determine the local maximum or local minimum for this graph of the function. So I'm creating a sign chart for the derivative graph, that is x equal to 1, x equal to 3, and x equal to 5. This is the sign chart for the derivative graph, that is f prime of x. Now let me put the corresponding sides to the left as well as to the right of each of the critical numbers. Looking at this graph, to the left of x equal to 1, the derivative graph is positive. So we can put positive over here. And to the right, that is from 1 to 3, it is negative. So I mark this as negative. And from 3 to 5, it is positive. So I mark this as positive. And afterwards, it is negative. So I mark this after 5. From 5 to 6, it is negative. So according to this sign chart rule, suppose if we have two critical numbers C1 and C2, and if the sign chart looks like this, so whenever it changes from positive to negative around C1, we say that C1 is a point of local maximum, and whenever the derivative graph changes from negative to positive around C2, we say that C2 is a point of local minimum. So let's follow this rule to this sign chart. So let's look at the critical point x equal to 1. It changes from positive to negative. So it is a point of local maximum. So I'm going to put at x equal to 1, it is local maximum. And similarly, we can see that for x equal to y, it still changes from positive to negative. So we see that 1 comma 5, that is 1 as plus 5 is a point of local maximum. And then from when you look at the another critical point at x equal to 3, it changes from negative to positive. That is this C2. So it is a point of local minimum. So we have x equal to 3 is the point of local minimum. So we have determined the increasing intervals, decreasing intervals, as well as the local maximum or local minimum from the derivative graph of this function.